Hi, my name is Andrew McLaren, and I want to help you understand when x is significant or not significant. This is something that ChatGPT is sometimes going to get incorrectly. So this question, I gave it to ChatGPT, and it assumed that x was not significant. It actually is significant here, but the change in the actual value is very, very small when we consider it being significant. So it is somewhat safe to assume it's not. Like you're gonna get pretty much the same value, but depending on your teacher, you would probably lose points for assuming that x is not significant. So let's talk about this a little bit more in detail. A lot of people think that there's just like a rule of thumb, like if you've got a really small Ka, like Ka that's a certain size, then it will be insignificant, this x, which is somewhat true, but it does also depend on the concentration that you're working with. So how I think about it is that it's about sig figs. So if you were to look at this number, like 0.10 molar, if you were to assume x is not significant and do the calculation, you can then plug it back in, like this 0.0010. You can go ahead and plug that value in and see, does it actually change the number? And in terms of the significant figures, this would round back down to 0.10. So if the original concentration is changed in such a small amount that it rounds back down to the original value, that's really what determines if x is significant or not. And in this context of this problem, we didn't need to solve for x. They gave us x. But you can work with just like this 0.10 value, and that would give you the Ka value that's appropriate. In this context here, this is one of those problems where we need to be careful in terms of our assumptions because they've given us a Kb value. We can work with this base reaction, assuming that x is the same for these two ions formed, and that was taken away from the original value of this compound, the NH3. The standard operating procedure for these things is to say, okay, that's a small Kb value, it's probably x is insignificant. But if you were to do that and plug in your value that you get for x, this 5.2 times 10 to the negative fourth, that's going to actually change your numbers. So if you were to look at this, this is like negative 1, 2, 3, 4. And so it absolutely is significant because this 0.52 would be changing numbers in this place value. So it's going to slightly affect your value, given that this was assumed to be accurate to the place values that where the x is coming into. It would change your values slightly. Now it's not very much, but it does change your values slightly. They did also ask for pH here, so you had to calculate the pOH and then figure out the pH. But here's what I had ChatGPT do. When it did the problem at first, it just assumed x was not significant, and it got this 10.72 value, which is also the wrong number of sig figs. So it kind of messed up the number of sig figs with given that Kb value. But then when you were to actually solve this using the quadratic equation, which is what we're trying to avoid when we're doing x is insignificant, because when you have this minus x here, you have to end up bringing it over to the other side of the equation, and you end up getting something that you have to solve for with the quadratic. But that isn't really our only option. But that is like technically the most accurate way to do this, or the quickest way to do this, is to use a quadratic. And you can see that we got a slightly different value. And when you were to compare it to what we calculated with our assumption, they're off by about 3%. So it's a pretty small difference. And like this, like less than 5% rule is what some people would be taught by their teachers. But in the context of this problem, it really is significant in terms of the place values. So this rule is not holding true in the context of this problem. And you can see that it's rounding out to a slightly different value. When you round out the final answer, down to 2 sig figs, I mean, it's kind of a weird thing, but it ends up being like the same value when you do that rounding. Um, it's kind of weird with pH and sig figs because you're not going to round it down to 10 necessarily because, yeah, it's like up to the exponent that we're thinking about. There is another option besides doing the quadratic. You can do guess and check. Like you can see like, oh, this value right here would make my x would make this, if I assume that this is not true, um, my denominator is like too big. And so I need to actually take a little bit away. And you can just kind of plug in what value you've taken away until you get to the actual KB value. So that is a way to avoid the quadratic, though it does take a fair amount of attempts with guessing and checking and seeing if your value is too low or too high from KB, given these different x values that you're just kind of guessing. So it's definitely not my recommended option for doing these types of problems, but it does kind of work ultimately. You can see in the context of this problem right here, the x is actually going to be significant, and it's the reason for that is that whatever value we have here that we get just from doing the math, we've got something that's 10 up to the -2 power here, and our x for the dissociation given this like pH is 10 up to the -3. So they're very, very close. So whatever this was added to or taken away from is significantly impacted by that dissociation. So if we were to have that value and we add x to it to get the original concentration, you can see that 5.6 is quite a bit different than 4.9. So it is oftentimes insignificant, but not always insignificant. And it really is a matter of comparing x to the values that you're working with, the initial and final value, and seeing does it actually change it or not in terms of those number of sig figs and place values that we're talking about.